66 million years ago, a rock the size of Mount Everest hit the Earth at 20 kilometers per second. The impact released more energy than a billion nuclear bombs. The sky turned black for years. Three-quarters of all species on Earth died. And from the wreckage eventually came us. But here's the question that paleontologists, evolutionary biologists, and cosmologists have been quietly arguing about for decades. What if that rock missed? Not by much. A few minutes earlier, it hits the Atlantic Ocean instead of the Yucatan Peninsula. The angle changes slightly. The depth of water absorbs the worst of the impact. The dinosaurs survive. What happens next is not what you imagine. The world that emerges from that single change is so alien, so structurally different from the one we know, that the word times unrecognizable times barely covers it. And the most disturbing part? Humans were never going to exist anyway. Here's the assumption everyone makes about this scenario. They picture dinosaurs and humans coexisting. T-Rex wandering through a jungle while early humans run away from it. Maybe humans evolved times anyway, just under more pressure. That's not how evolution works. At the time of the Chicxulub impact, mammals had existed for approximately 165 million years. And in all that time, with dinosaurs dominating every major ecological niche on land, mammals had been unable to grow larger than a small cat. The largest mammal alive 66 million years ago weighed approximately 15 kilograms. Most were nocturnal, burrowing, insectivorous. They were ecologically time-suppressed, times not by predation alone, but by competition for every resource that mattered. Paleontologist David Jablonski, University of Chicago, published analysis in 2017 showing that mammal body size and ecological diversification remained essentially flat for the entire 165 million year coexistence with non-avian dinosaurs, and then exploded within 300,000 years of the extinction event. 300,000 years is nothing in evolutionary time. It's a snap of the fingers. The moment the dinosaurs disappeared, mammals didn't gradually expand. They erupted times into every available niche simultaneously, like a gas filling a vacuum. If the asteroid misses, that vacuum never forms. The small, nocturnal, burrowing mammals of the late Cretaceous stay exactly where they are, small, nocturnal burrowing for another 66 million years. Primates never emerge. Great apes never emerge. Hominins never emerge. You are not a close call in this scenario. You are an evolutionary impossibility. Here's where the story gets genuinely strange. Most people picture dinosaurs as the Jurassic Park version giant, slow, reptilian, already at their peak. Maximum dinosaur. End of the line. But paleontologists looking at the late Cretaceous fossil record see something completely different. They see acceleration. Dale Russell, Canadian Museum of Nature, published a now famous 1,982 thought experiment later, supported by expanded fossil analysis, examining the evolutionary trajectory of time's Troodon formosus, a late Cretaceous theropod with the largest brain-to-body ratio of any known dinosaur. Russell calculated that if the Troodon lineage had continued evolving at its documented rate for another 60 million years, the resulting creature would have had independently an upright bipedal posture, binocular vision, opposable digits, and a brain volume approaching that of early times Homo sapiens. He called it the Dinosauroid. The scientific community debated the specifics for decades. But the underlying principle that at least one dinosaur lineage was on a trajectory toward dramatically increased cognitive complexity has held up. We know this because we have living proof. Birds are dinosaurs. Specifically, they are avian theropods, the direct descendants of the same lineage that produced Velociraptor. And modern birds, particularly corvids and parrots, demonstrate problem-solving, tool use, long-term memory, and social learning that rivals primates. Alex, the African gray parrot, studied by Dr. Irene Pepperberg at Harvard for over 30 years, demonstrated a functional understanding of zero as a mathematical concept, a cognitive achievement previously considered exclusive to humans and great apes. That's a dinosaur doing abstract mathematics. Now, give that lineage 66 million more years of uninterrupted evolution, The dinosaur that emerges at the other end of that timeline is not the monster from the movies. It might be something uncomfortably close to a person. Even setting aside intelligence, the structure times of the planet in a non-extinction world would be fundamentally alien. Flowering plants, angiosperms, were only beginning to dominate terrestrial ecosystems in the late Cretaceous. Their spread was accelerating, but the world was still significantly coniferous. Grasses had barely appeared. Without the extinction event, paleobotanist Michael Donoghue, Yale University, argues that angiosperm diversification would have continued, but along a completely different trajectory, shaped by the feeding pressures of massive herbivorous dinosaurs rather than the mammals that replaced them. Sauropods, the long-necked giants like Brachiosaurus, were browsing at heights of 9 to 12 meters. No mammalian herbivore that has ever existed comes close to that. The entire canopy structure of forests in a dinosaur-dominant world would have been shaped by animals removing vegetation at heights that no mammal can reach. The grasslands that dominate Earth today, the African savanna, the American Great Plains, the Eurasian steppe, almost certainly don't exist in this timeline. Grass co-evolved with grazing mammals. Without the mammalian explosion, grasses stay marginal. No grasslands means no grazing megafauna, no wildebeest migrations, no bison herds, no horses. The planet's biomes, the actual geographic zones of life, reorganize completely around what dinosaur feeding behavior demands. The Earth, in this timeline, doesn't just have different animals. It has a different time shape. Here's the part of this scenario that nobody models correctly. Climate. The late Cretaceous Earth was significantly warmer than today. Average global temperatures were approximately 4 to 10 degrees Celsius higher. Sea levels were dramatically elevated. Shallow inland seas covered large portions of North America and Europe. There were no polar ice caps. The Cenozoic cooling trend, the 66 million year gradual drop in global temperature that produced the ice ages, the tundra, the Arctic and Antarctic ice sheets, was driven in part by the time's biological changes, times that followed the extinction. Specifically, forests of broad-leafed deciduous trees, which expanded massively after the extinction, have different carbon sequestration rates than the coniferous and fern-dominated landscapes of the Cretaceous. The mammalian explosion changed what grew. What grew changed the atmosphere. The atmosphere changed the temperature. Climate scientist Lee Kump, Penn State University, published modeling in 2011 suggesting that without the Chicxulub impact and subsequent biological reorganization, global temperatures might have remained 3 to 6 degrees warmer through the present day. In this timeline, there are no ice ages. No ice ages means no glacial cycles driving the kind of environmental variability that, as we covered in a previous video, Richard Potts identified as the primary driver of rapid human brain evolution. Even if some primate-like creature somehow emerged in this warmer, more stable world, the environmental pressure that forged human-level intelligence probably doesn't exist. Stability, it turns out, is the enemy of intelligence. The asteroid didn't just clear the board. It made the board unstable enough to produce something that could think. Let's run the scenario forward anyway. Assume the Troodon-like lineage does develop primate-equivalent intelligence over 60 million years. What does their civilization look like? Completely different from ours. And not just aesthetically. Human civilization is built on a specific biological foundation. Primate hands with full opposable thumbs, forward-facing binocular vision, a vocal apparatus capable of complex speech, and a social structure built around pair bonding and extended family groups. An intelligent theropod dinosaur would have a completely different toolkit. Theropod forelimbs in the late Cretaceous were already partially reduced. Think of the T-Rex arms, or the slightly more functional velociraptor forelimbs. An evolved, intelligent theropod might rely far more heavily on feet times for manipulation. Some modern birds use their feet with remarkable dexterity for exactly this purpose. Their communication system would almost certainly be primarily times visual and vocal times rather than gestural. Birds communicate through extraordinarily complex vocal and visual displays, And an intelligent descendant would likely develop language through that pathway, rather than the manual gesture pathway that many linguists believe predated human speech. Their architecture, their tools, their cities, if they built them, would be optimized for a creature with a completely different body plan, different sensory priorities, and potentially a different social structure entirely. Dr. Ronald Orenstein, University of Toronto, has speculated that intelligent avian descendant civilizations might be fundamentally more times communal times than human civilization, given that modern birds show more cooperative nesting and resource sharing behavior than most mammals, with less emphasis on individual ownership and territorial accumulation. A civilization built by intelligent dinosaurs might not have invented war the way we did, or it might have invented something worse. We genuinely don't know. Here's the truth that makes this entire thought experiment collapse inward on itself. We keep framing this as, what if dinosaurs had survived instead of us? But that framing is wrong, because we times are times the result of the dinosaurs not surviving. Every system in your body, your warm blood, your placental reproduction, your enlarged neocortex, your upright posture, your hands is an evolutionary solution to the problem of living in a world times after times the dinosaurs. Mammals didn't evolve times despite times the dinosaur era. They were times shaped times by it. 165 million years of hiding in burrows, developing night vision, developing smell over sight, developing social bonding under predation pressure. All of that is written into your biology right now. You are not the alternative to the dinosaur world. You are its consequence. The asteroid didn't interrupt the story of life on Earth. It wrote the chapter that you're living in, 66 million years ago. A rock the size of Mount Everest hit at exactly the right angle, in exactly the right place, at exactly the right moment. A few minutes either way, and the Yucatan takes a different hit. The dinosaurs limp through, the mammals stay small, the primates never emerge, the hominins never walk, the humans never think. And nobody is around to ask what would have happened if the asteroid had missed. The question only exists because the asteroid didn't. You are not a survivor of that collision. You are its answer.